Welcome to this video on the software process model, part of our series on software development. A software project is the complete procedure of developing software, from gathering requirements to final testing and ongoing maintenance. At the core of any project is the program, a set of instructions written in a programming language to perform specific tasks efficiently. Software is the broader term, encompassing all computer programs, data, and instructions that work together on a computer system. To successfully deliver these projects, we rely on software project management to plan, organize, and control resources and timelines. This process is guided by the SDLC, or Software Development Lifecycle, a framework for planning, developing, testing, and maintaining systems. The SDLC is crucial because it ensures software meets user needs, manages risks, and helps deliver high-quality results within budget. The SDLC consists of 7 main phases, starting from requirement collection and moving through to final maintenance. Phase 1 is requirement collection and analysis, where teams work with stakeholders to define precise needs and establish project timelines. Next is the Feasibility Study, which evaluates the economic, legal, technical, operational, and schedule viability of the proposed system. In Phase 3, we focus on design, identifying key components, and establishing the system structure based on our prior analysis. Phase 4 is coding, the longest part of the process, where developers build the system using various programming tools. Phase 5 is testing, an iterative process to identify and fix bugs before the software reaches the end user. Once testing is complete, the 6th phase is deployment, where the final software is released to the production environment. Finally, Phase 7 is maintenance, involving ongoing bug fixes, software upgrades, and feature enhancements to keep the system current. A data flow diagram, or DFD, visually represents how information moves through a system. It details inputs, outputs, data stores, and sub-processes, providing a clear map for either analyzing current systems or planning new ones. DFDs utilize specific standardized symbols. Arrows represent the direction of data flow, circles indicate processes, parallel lines represent files or data stores, and rectangular boxes denote data sources or sinks. The zero-level DFD, or context diagram, offers a high-level view. It represents the entire system as a single central process, showing its primary interactions with external entities. In a Level 1 DFD, we decompose that central process into multiple sub-processes. This layer highlights the main functions of the system, breaking down the high-level operations into more specific components. The 2-level DFD goes even deeper, refining parts of the Level 1 diagram. It is an excellent tool for documenting the precise details and functional requirements of a system. Thank you for watching this overview of data flow diagrams and their role in documenting system requirements.